lovely one, it's me, Helen the Great. Now, this is a question that challenged even me. Why? Because it wasn't conventional, not because it was difficult. And that's one of the reasons I really like it. Now it says, given that this side is equals to that side, where x and y are integers, in other words, they are whole numbers that are either positive, negative, or equal to 0, find the values of x and y. Okay, but the bases aren't the same. So what do? Let's start by simplifying it, and we're going to simplify it by factorizing. Like I said, factorizing makes me feel clever. I enjoy it. Why? Because it's always the same. First you look for a common factor, then you look for a difference of two squares, then a trinomial, then a sum or difference of two cubes. But that hardly ever comes up. Okay, on this side, our 2 to the power of x is common, but on this side, 3 to the power of y is common. So let's take those out. 2 to the power of x, and we're left with 2 to the power of 1, which is 2, and 2 to the power of x disappears, leaving 1 behind. That's nice and easy, isn't it? And on the other side, we take out 3 to the power of y as a common factor, which means we're left with 3 squared, let's write it down as 9, minus, well, 3 to the power of y is taken out, so we're minusing 1. So now we have 2 to the power of x times by 3, and 3 to the power of y times by 8. Let's play with it a bit more. And what I'm wanting to do when we play with it is to write the 8 as a product of its prime factors. So 2 to the power of x times by 3 is equals to 3 to the power of y, and 8 is of course 2 to the power of 3. Now let's think about this logically. If 2 to the power of x times by 3 has the same value as 3 to the power of y times by 2 cubed, could we say that 2 to the power of x has the same value as 2 to the power of 3, and that 3 to the power of 1 has the same value as 3 to the power of y? It's an interesting way to look at it, isn't it? And it's completely right, too. So x is equals to 3, and y is equals to 1. Now this question was solved with logic. And you must never, ever underestimate your instinct with doing things like this. Don't just follow a system. Think about it for a while. Much love.